Good morning. All right, you guys. So we are on 6.2 day 1. We take 6.2 kind of slow. We're going to start up with a warm-up today. It says to solve for x, and we have 2 times e to the x minus 1 quantity squared minus 10 times e to the x minus 1 quantity plus 12 equals 0. And you're solving for x, okay? So I do want you guys to try this on your own, but I'm going to give you some hints here. I want you to pay attention to some things like this e to the x minus 1 here, and this one's here. So my suggestion is what you should do to solve for x is to make this simpler. E to the x minus 1, that looks kind of crazy. Can you replace that with something to do it for now and then put it back in at the end so that you could solve for x? Can you figure it out? Make sure you give yourselves a shot. Pause this video and try it. See how far you can get, and then when you get stuck, you can stop and go back to the video. Now in the classroom, you would be trying this. So hopefully you did. If you didn't, I can't control that, so whatevs. But here we go. So what I meant was what we can do is we can substitute in a different variable so that we can have this in a simpler version so that we could do the math, the easy math behind it, and then plug in this ugly thing back inside and then finish solving for x. We call that using a dummy variable. Okay, so when we're using a dummy variable in calculus, we usually use a u. So we're going to replace this e to the x minus 1 with a u. Okay, so we're going to substitute. And we're going to let u equal the e to the x minus 1. All right, and let's do it. Okay, so when we do this, we'll have 2, and instead of e to the x minus 1, we're going to replace it with a u squared minus 10, and then instead of e to the x minus 1, replace it with a u, and then plus 12 equals 0. Well, now we have a quadratic. So we should be really good at factoring and solving for x when we have a quadratic, right? So what I would do first is I noticed that all 3 terms have a 2 in common. I would factor out a 2 first, and I would get u squared minus 5u plus 6 equals 0. And then I would factor that quadratic. It's an easy trinomial. 2 numbers that multiply to 6 and add up to -5, they both need to be negative because a negative times negative will be a positive number, and it's got to be 2 times 3 because -2 times -3 is 6, -2 minus 3 is -5. And then when we solve for u, we break them apart and set each one equal to 0. So I'm going to get u equals 2 and u equals 3. But remember, we weren't solving for u. We're supposed to solve for x. So now we need to put the e to the x back in for the u. So put it back. So remember, we're going to put e to the x minus 1 equals 2, and e to the x minus 1 equals 3, putting it back in for u. And now we need to solve for x. So this should look familiar at this point because you learned how to do these problems back in Math 3 when we were dealing with logs. So let's solve for x. We have to isolate the e to the x term. So I'll get e to the x equals 3. Add 1 to both sides here also, and you'll get e to the x equals 4. There's a couple different ways to think of doing this. In my class, I taught you guys to take a log on both sides to get the x down out of the exponent. So because it's an e, it has to be a natural log because natural log has base e. Right, and we have to do it on both sides. I'm just doing it both at the same time. The reason why is, remember, if you guys had me last year, the idea is to get the double base. And once you get the double base, the x gets to come down. So, and remember, with natural log, you don't need to write base e. I only wrote it so you could see that we have the double base. So on the other side, it's just the natural log of 3. Over here, we got the double base, so x gets to come down, and we have the natural log of 4. So we have x equals natural log of 3 and x equals natural log of 4, and those are the two solutions for x. And that's the warm-up. Hey, you guys. All right, so we are on 6.2, the day 1 notes. You've already done your warm-up. We are finding antiderivatives with substitution. So these are handwritten notes, yeah. So that's just what we're using. But they are very clear, so I hope you think that they are as well. Your homework assignment is off of a worksheet, which I'll show you at the end of this lesson. It'll be attached under the homework assignment, numbers 1 through 10, all, and you need to check your answers. And I'm going to model how to do that with some of these examples. I'm not going to do it on all of them, but I will do it on at least the ones on this first page. We have a list of steps to use here. And I'm not going to go over these until we get to a problem. So once I start going through these examples, we'll go through each of these steps and what they mean to do. Okay, so remember the warm-up, and we had to substitute in a u for the e to the x minus 1. It's that same type of idea. That's why that was the warm-up, okay? So step 1, it says to set up a dummy variable, let u equal something, and we also need to find the derivative, du, so the derivative of u. Okay, so usually when we're trying to set up a dummy variable, we're looking for what is being plugged into a function. And it's usually something that is to the highest power in an expression, such as this x squared plus 1. Okay, it looks like it's being plugged in there. We don't need to worry about this to raise to the second power. We just want to care about the x squared plus 1. And the more you practice this, the more you're going to understand what to look for and how to do it. Okay, so here is our step 1. Daisy does not like being outside. We're dog sitting Daisy again today. All right, so we're gonna let u equal x squared plus 1. Okay, and then we're gonna take the derivative of that. So we're gonna find du by dx, and the derivative of x squared is a 2x. And the derivative of a constant is 0, okay? And we need to get the du by itself, so we need to multiply the dx to the other side. So we will get that du equals 2x dx, okay? So here's what we have. We're going to replace the x squared plus 1 with a u. And do we have the du equals, do we have the 2x dx? We do. We have the 2x and the dx right there. So that's going to be all replaced with a du. So step 1 was setting up the dummy variable. Step 2 was to fix the question so du exists. Now for this problem, we don't have to do this step. We don't have to fix anything because our du needs to be a 2x dx, and we have a 2x dx. So we don't need to fix it at all. You'll see what I mean in future problems. Okay, step 3, we need to substitute u and du. Let me switch to a different color. So this is step 3. We need to switch to u and du, so we're going to have the integral of, instead of x squared plus 1, we're replacing that with a u, so that'll be u squared, and we're replacing the 2x dx with du. Doesn't that look naked? It looks a lot smaller than the original, but that's why we use this u substitution, because we can handle that. And then once we've done the hard math behind it, we could plug the x squared plus 1 back in and finish it off. Okay, so that was step 3. Step 4 says to integrate. So now we're going to integrate. So remember, we raise the roof and divide by the sum. 2 plus 1 is a 3. So this will be u cubed over 3 plus c. But I'm not done yet. We integrated. Now step 5 says to simplify. There's nothing to simplify for this particular problem. Okay, so the next step would be step 6, substitute out the dummy variable. So we need to bring the x squared plus 1 back in for u. So we'll get x squared plus 1, but remember the u is cubed. So to the third power over 3 plus c. So that's the answer, but we need to check this. So I'm going to check it. So to check it, you need to take the derivative of this and see if you get back to the original. So to take the derivative of x squared plus 1 quantity cubed, I'm going to have to use chain rules. I have to take the derivative of the inside. The derivative of x squared is a 2x. The derivative of 1 is just a 0, so 2x times. Now the derivative overall, I got to bring the 3 down. And then times the quantity on the inside doesn't change. And then we have to take this down 1. 3 minus 1 is a 2. Remember, this is all over 3. The 3's are going to cancel. And I'm basically going to have 2x squared plus 1 quantity squared. And that's what we had in the original. So check. So let's also take note of all the steps that we did. So step 3 was to substitute in the u and the du. Step 4 was to integrate. So this was step 3 and step 4 here because actually step 4 was this part right here. Okay. And then step 5 was to simplify, but there was no simplifying. And then step 6 was to substitute out the dummy. So this one is step 6, which got us to our answer. And then step 7 was to check it. Okay, so we've got all our steps in there. Okay, I'm not going to write out all the steps every single time. I just want to show you how it's flowing pretty much, okay? All right, let's try another one. We've got the integral of 5 cosine 5x dx, okay? So yeah, it's a trig problem, but we still have to look for what is being plugged in. The 5 is not it because it's a constant in front of the cosine. The cosine isn't it because it's not being plugged into anything, but that 5x is being plugged into the cosine. So let's let u equal the 5x. And then let's take the derivative of u. So du by dx equals the derivative of 5x is a 5. And we need to take that dx and multiply it over. So du will equal 5 dx. So I'm actually going to skip this step from now on because we know that we're always going to have to multiply the dx over. So we're just going to go straight to it from now on. Okay? All right. So next thing, well, do we need to fix this? Do we have the 5 dx? We've got a 5. We've got a dx. So together, yes, we do have the 5 dx. So we don't need to fix the question so that du exists. It exists in this problem. All right, step 3, substitute the u and the du. Okay, so we have the integral of, we know the du is there, the 5 and the dx, so we know we've got the du. And then cosine, we're going to replace, or sorry, not the cosine, we're going to replace the 5x in the cosine with a u. So we write this cosine of u du. Okay, so Lucas, those sentences better be neat. I better be able to read it on your circle map.
No, go reset.
Okay, that's what I thought. You did it in like 5 seconds. Anyways. Okay, so let's integrate this. So when we integrate cosine, the antiderivative of cosine is sine. So that's sine of u plus c. That was pretty easy, huh? I guess I don't really need the brackets there. So now we integrated, that was step 4. There's nothing to simplify, that's step 5. Substitute out our dummy variable. So we got to put the 5x back in. So we'll get, oops, I unclicked it. So we'll get sine of 5x plus c. So that is the answer. And let's check it. So let's do the check part. So the derivative of sine of 5x. Well, we have to do chain rules. We have to take the derivative of the inside. The derivative of 5x is a 5 times the derivative of sine is cosine, and then we keep the stuff inside there. So 5 cosine 5x, and that is what we have there. So check. That's what you're going to need to do for your homework. You have to do the check part also. Okay. Number 3. We have the integral of x times the quantity x squared plus 1 squared dx. So remember, we're looking for what's being plugged in. And like I said, it's usually going to be the stuff to the highest degree. Plus, when you think about it, you're going to have to take the derivative of this to find the du, and the du needs to be a level down from it, so an exponent down. And when we take the derivative of that, this will be. Okay, so let's let the u equal the x squared plus 1. Not the quantity squared, just the stuff inside the parentheses. All right, let's take its derivative. Du by dx equals the derivative of x squared is a 2x. The derivative of 1 is 0. Oh, shoot, I forgot to skip this step. Oh, well. So you got to multiply the dx over. So it's du equals 2x dx. Okay. Do we have a 2x dx? Well, we have a x dx. We don't have a 2. So we actually have to do step 2 this time. We have to fix it. So make sure you have a different color. I have this purple pen here. I need a 2 out front. So guess what? I'm just going to put it there. Okay. But you're probably thinking, what? You can just do that? Yes, I can. But there is a catch. I have to compensate for it being there. So I have to act like it's not even there by putting a 1/2 in front of the integral. Because what's 1/2 times 2? A 1. So it's really not there. It's still a 1, but I'm putting it in so that I can have it in for my problem. So I'm making it there. I'm fixing it, but it's still the same problem because 1/2 times 2 is still 1. So it's still the same problem. Nothing's different. I'm just writing it so that it works for what I'm trying to do here, this u substitution. Okay, so now I have the 2x dx, and I can write this. The 2x dx is our du, and we're replacing the x squared plus 1 with a u, but remember that's to the second power, so it's u squared. Okay, so, and don't forget there's a 1/2 out front. All right, so now let's integrate. Lipstick taser, right mission? So we have this 1/2 out front, and the antiderivative of u squared, we've got to bump it up, got to raise the roof, and we'll have u cubed over 3 plus c. Now I can simplify this because I have a 1/2, so and times the u cubed over 3. I can make that over 6 by just multiplying it. And I need to substitute out the dummy variable, step 6. So let me switch to a different color for that. I'll use this orange. So instead of u cubed, I'm plugging in the x squared plus 1 back in. So I'll have x squared plus 1 quantity cubed, because it's cubed, all over 2 times 3 is a 6, plus c. And that would be the answer. But now we gotta check it. So here's the check part. So we have to use chain rule on this. We have to take the derivative of the inside. The derivative of the inside would be a 2x, and the derivative of 1 is 0, so it's just 2x, times a derivative overall, so I have to drop the 3 in front, keep the stuff on the inside, but I got to take it down 1 exponent. 3 minus 1 is a 2, and that's all over 6. Well, 3 goes into 6 twice, and then these 2's cancel, so all I have left is x times x squared plus 1 quantity squared, which is what I started with. So yay, it checks out. Woohoo! And that's number 3. All right, number 4. I'm sorry, you could see the markings on the other side of the paper, but I think we could still do this. So we have the integral of the square root of 2x minus 1 dx. I think it's easier to see what the u is going to be because obviously 2x minus 1 is plugged in to the square root there. So we're going to let u equal the 2x minus 1. Okay, and then take the derivative of that. So du is going to equal, well, the derivative of 2x is a 2. Derivative of negative 1 is a 0. So it's a 2, but remember we multiply the dx back over, so it's a 2 dx. Do I have 2 dx? I've got the dx part, but I don't have the 2. So I have to do step 2. I got to fix it. So to make it have the 2, I can just put it out here. But if I do that, I have to make sure I have its reciprocal out front, so it's really a 1, so that nothing really is changing on there. Okay. All right, so now we can rewrite the integral with our u substitution. So it'll be 1/2. And remember, the 2 dx we can replace with du. Oops, I need my integral. Du. And the square root is not going to be of 2x minus 1 anymore. We're going to replace that with a u. So it's just square root of u. So we have 1/2 integral of square root of u du. Okay. So now we need to rewrite this because we're going to have to take the antiderivative, and we need to see an exponent there in order to do that. So we can write this as u to the 1/2 power. Okay. So when we take an antiderivative, we got to raise the roof. So we've got to add 1, but because it's a fraction, I'm going to add a 1, but have it with a common denominator. And then you divide by it. So we're going to divide by, what is that, 3/2? But dividing fractions easy as pie, flip the second and multiply. So we'll have a 1/2 out front. And then this is a 2/3 when you flip the second and multiply. U 1/2 plus 2/2 is 3/2, right? Plus C. What's beautiful about this is these twos cancel. Yay. So I have, let's convert this back to a square root. So square root of u cubed. So square root of u cubed all over 3 plus c. And that is the simplified form of, oh, shoot, why did I box that? I shouldn't have boxed it because what did I not do yet? I got to put the 2x minus 1 back inside. Oh my gosh. Here we go. Next step. Keep unclicking my pen, so I keep forgetting that I didn't unclick it. Or I didn't click it. All right, so I'm going to plug back in the 2x minus 1 for the u. So I'm going to have the square root of 2x minus 1. But that u is cubed. So to the 3rd power all over 3 plus c. And that's what I'm going to box. Can't forget to plug it back in. You shouldn't have any u's in your answer. Your final answer should have x's back in it. Okay. I'm not going to check this one because you guys just need to trust me that this is the right answer. And it is. Actually, double and triple check this one with the derivative to make sure, because I was doing it wrong. The derivative was, I was doing wrong at first. And then I was like, what am I doing wrong? And then I figured it out. That's what happens when you're trying to do it too fast and then you forget to write the cube. That's what I was doing wrong. But anyways, you don't need to know that. All right, number 5. We have the sine, or the integral of sine squared of 3x, cosine of 3x dx. Okay. Well, basically, because the sine is squared, that's the function that I need to let u be. Not the squared part, just sine of 3x. Okay. So I know that that's kind of hard to think of, but that's why we're doing so many examples, so that you'll be more successful on the homework, just so that you see all the types of things that you're going to see. Okay. So this is going to be what we let u be. We're going to let u equal sine of 3x. Okay. And then we need to take the derivative of that. So du, the derivative of sine derivative of sine is cosine, but I have to use chain rule first. So I have to take the derivative of the inside. The derivative of 3x is a 3, and then like I said, derivative of sine is cosine. So 3 cosine 3x, and then remember we multiply the dx over. So it's 3 cosine 3x dx. That is Daisy barking in the background. Oh my word. Lucas, let her out! Sorry, didn't mean to yell it, but hopefully that wasn't too loud. All right, so next step is we need to do the substitution part. Do we have the du? Do we have 3 cosine 3x? we have the cosine 3x, the dx, but there's not a 3. So we have to fix it and put the 3 in front. But if I put a 3 here, I have to make sure that I put something out front of the integral that cancels it out to a 1. Its reciprocal is 1/3, and that's going to be what does it. Okay, so I'm going to have 1/3. Remember, the 3 cosine 3x dx, that is all what makes our du. And sine squared of 3x, remember, we're replacing u with that, so this is just going to be u squared.
Hi.
Lucas says hi.
Bye.
So look how clean that looks. It simplifies down to barely anything. We could totally deal with that. Okay. So we take a scary looking problem, use u substitution, make it a lot smaller, do the hard calculus math, and then put the stuff back, and all the hard stuff's already been done. All right, let's take the antiderivative. So we'll have 1/3 out front. We have to raise the roof. So this will be u cubed over 3 plus c. Okay. So from there, we need to plug back in the x's. So we have to substitute out our dummy variable. So let me switch colors here. I was like, what am I trying to say here? So obviously this is going to be over 9. 3 times 3 is 9. And for u, I'm substituting back in sine of 3x. Now, because the u is cubed, we could put the cube here, or you could put parentheses around the whole thing and raise it to the 3rd power. It means the same thing. And then plus c. And that is the answer. Now, of course, on your homework, you have to check every single one. Just because I don't want this to be too long, I'm not showing you the check on all of these, but they are the correct answer, promise. All right, number 6, integral of cosine squared x sine x dx. So obviously we know, because the cosine is squared, that this must be what our u needs to be. So let's let u equal cosine of x. Take the derivative. So the derivative of cosine is a negative sine x, and then don't forget the dx. Do we have negative sine x dx? We have the sine x and the dx, but not the negative. So we have to fix it. We have to use step 2. So I need to put a negative out front, but that means I also need to have a negative out front of the integral, because a negative times negative is positive. So it's really still positive, but I need that there for this substitution. Okay, so now let's substitute it out. So we'll have the negative in front of the integral. And remember, the negative is part of the du. I need negative sine x and dx, and that all is for du. And then cosine squared x, well, we're replacing the cosine of x with a u, so this becomes just a u squared again. Okay, so let's antiderive. So when I take the antiderivative, I'll have -1, and then I got to raise the roof. So that'll be u cubed over 3 plus c. Okay, and then I got to substitute back in the x's, so I got to get rid of the u's. So I'll have -1, and then I got to plug in a cosine. So cosine of x, but it's to the 3rd power, so cosine cubed x over 3 plus c. And there we go. Hey guys, all right, so now number 7. So we got to figure out what our u needs to be. And so when you're not sure which one it is, because we've got 2 quantities here that could be it, remember what you do with the u. You take its derivative. So if we were to take the derivative of x squared plus x, won't that be 2x plus 1, which is that? So that will be our du. So this is going to be our u. So let's let u equal the u squared, sorry, not u squared, x squared plus x. Okay, so when we take the derivative, we'll have du equals 2x plus 1, and then don't forget the dx. And do we have the 2x plus 1 dx to support our du? Yes, we do. So we don't have to fix anything. We have everything that we need. Okay, so let's do our u substitution. We'll have the integral of the x squared plus x, we're replacing with a u. And the 2x plus 1 dx, we're replacing with a du. As simple as that. Something so huge is just so little when we do the u substitution. Okay, so now let's take the integral. So we've got to bump this up. So it would be u squared over 2 plus c. And then we have to switch out the u, the dummy variable. So let's do that now. So we'll put the x squared plus x back, but remember it's u squared. So it's going to be x squared plus x quantity squared all over 2 plus c. And when you check it and take its derivative, you will get back to the original. Okay. All right. Number 8, last one, almost done. We have the integral of negative 4x over 1 minus 2x quantity squared dx. And I know it looks crazy, but remember, the thing that's squared is usually our u, and in this case it is. So we're going to let u equal the 1 minus 2x. Remember, not the squared part, just the stuff inside the parentheses there. And then when we take the derivative, we'll get du equals, derivative of 1 is 0. Derivative of negative 2x is just a negative 2. And then remember, we have to multiply by dx, so negative 2 dx. Oh, that's right. There's a typo in this one. Shoot, I almost forgot. And Mrs. Ardito told me that there was a typo on this one. This 1 minus 2x, that should have an x squared on the inside. My bad. Shoot. So when we take the derivative, we have to bring the 2 down. That'll be a negative 4x dx. I'm going to use a different color to go over that. Negative 4x dx. Okay. Do we have the negative 4x dx? Well, if we look at what we've got here, I've got the negative 4x. I've got the dx. So yes, we have it all. We don't need to fix anything. So we could just go straight to our u substitution. Oh, Princess Leia, digging in that trash can again. This is the 3rd time she's dug in this trash can. Hold on, guys. Let me go grab her. No. Out of there. She thinks that there's food in the trash can. She's a pug, so she's always searching for scraps, and there is no food in my office trash can. I don't allow it in here. Anyways, okay. So let's do our substitution. So we'll have the integral of, we're replacing the negative 4x dx with du. And we're replacing 1 minus 2x squared with u. So, but this is in the bottom. So we'll have just a 1 up top and then u squared in the bottom. Okay. So when we do this derivative, we need to write this as a non-fraction. That's what I was trying to say. Like, what am I supposed to say here? So let's rewrite this as u to the negative 2nd power. Okay. And then we need to antiderive it. Let's take that antiderivative. So we got to bump it up, raise the roof. Negative 2 plus 1 is a negative 1. So I will have u to the negative 1 over negative 1 plus c. Okay. And then we need to substitute out the dummy variable. And let's go ahead and do that now. So we're going to put the 1 minus 2x squared back in for u. But that u to the negative 1, let's drop it like it's hot and put it back in the denominator. And because we're dividing by negative 1, it's the same as multiplying by negative 1. So let's also just bring it up to the top. So we'll have negative 1 in the top. And we'll have the u to the first and the bottom. So just a 1 minus 2x squared in the bottom. And you don't really need parentheses there either, but whatever, it doesn't hurt either. And there we go, plus c. And there's our answer. All right, and that's everything. Okay, so let me show you guys the homework. I was about to end it. So let me pull out that worksheet. Your homework is on this worksheet that is attached under this assignment, okay? You only have to do numbers 1 through 10. just like the notes, but you have to make sure that you check all the answers like we were doing at the beginning of the notes. That's why I highlighted this. Check your answer by differentiation, so taking its derivative and making sure you get back to the original. Okay, and that's everything, you guys. So yeah, I'll see you later.